So all in all, we found that there were seven or these three different categories of low carbon strategies that we saw throughout the project, and we're gonna use these seven strategies in the three categories to guide the rest of the conversation. So for the next part of the conversation, I'm gonna hand this back over to you, Bev.
Yeah, so Meredith mentioned these seven strategies, and I think it's just really important as people who are obviously interested in embodied carbon who are showing up to this webinar to take a look at all seven of these strategies on all the projects you're looking at. These are high impact, low cost things across a lot of different projects that were successful. They might not be successful in every project, but I think every designer should be thinking about all seven of these as they go through and start on a project. So I'm going to be talking a little bit about some examples and case studies of projects that you are in this first category of using less. Um, the easiest ones and the ones that were saving money, the way Aurora was talking about, often did propose less space. And so the using less comes in sort of three major flavors that we saw in projects. First, reuse and rehabilitation, keeping existing structures, whether they were parking structures, foundations, sometimes just the structure, sometimes even just a facade. Using less through space optimization. So basically building less square footage than the owner was originally thinking through creative stacking, using the same space for multiple purposes, and sometimes even adjusting ceiling height so that there was less volume of building built. And then using less through interior efficiencies. So we're going to talk first about reuse and rehabilitation, a case study. So hold on, I'm sorry, I lost my notes here. So 80 West Broadway is a really interesting reuse example. It preserves an 1890 historic restaurant. You'll see that at the front of that image. It's a 4-story masonry and copper facade building. It builds up and around it with a timber structure, and the resulting design maintains the integrity of the previous space, but also creates a new mixed-use building. In schematic design, this team evaluated 3 different structural systems and chose mass timber, glulam framing, and CLT panels. Can you guys still hear me? Yeah? Okay, sorry, I got something running in front of my screen. The team designed the exterior rain screen system, thinking not only just about thermally efficient materials like mineral wool, board insulation, but they also thought about lighter weight. So they used thin brick in this case. That lighter weight of the thin brick allowed for a lighter and lower embodied carbon structural system and concrete foundation. The resulting lighter, thinner structural members also allowed for larger windows and more use of internal daylighting in the building. And this project, even though I've been highlighting some of the strategies related to reuse and lighter weight design, this project also hit a lot of those other 7 strategies. You see the check marks on the left side, basically everything from low carbon concrete to interior efficiencies. So they really hit almost everything with this project. I will say, like, I've seen in New York City quite a few buildings where they keep a historic structure like this and build up and around it. So I'm seeing more and more of this going forward. So space optimization is also another category of using less. And Aurora highlighted the 2 grand prize winners who are really very creative in using this kind of strategy. Jones Library and Sustainable Engineering Laboratory both featured really creative ways of optimizing the space so that there was less material, and then also ended up saving owners money. At Jones Library, that team multi-purposed several of the areas and were able to build less in that addition in particular than was originally proposed. And then next slide. And Sustainable Engineering Laboratory, in this case, there was a really interesting, if you take a look on the left and right sides, a laboratory space on the left. You can see level 2 to level 3 and then to the roof. It requires higher ceiling heights. On the right-hand side, instead of just keeping the ceiling heights the same, they used a skip gap measure with an elevator with in between stops so that there's 3 levels of office. So if you basically by creatively stacking and doing something that's somewhat untraditional, they were able to reduce the amount of square footage in this building. And if you also take a look at the bottom in the red area, what was originally programmed as a subsurface basement for mechanical rooms was moved to the top of the building. And by repositioning that bottom space, the project used significantly less concrete, which really had a big impact as well. Through better space optimization between schematic design and design development, this team was able to reduce the net program area by 3% and a 15% reduction in gross area. That actually led to 25% less steel tonnage. Again, by building less and space optimization, both the cost savings and an embodied carbon savings. And I'm going to hand it back over to Aurora to cover more interior efficiencies.
Great. So with interior efficiencies, we want to highlight one more detail about sustainable engineering labs. You might have caught me earlier saying the term CLT when referring to this deck, but actually this team went with dowel laminated timber, or DLT. And this project is a bit unusual in using DLT as a floor slab. And in this case, you can see exactly how they approach the acoustics through this section on the left here, where they basically created the DLT such that it was routed with grooves that accept the acoustical foam. And this delivered a noise reduction coefficient of about 0.7 from the structure alone. This approach to allowing the acoustic system to be integrated into the DLT provided actually a slight cost premium over CLT, but it delivered cost and carbon and aesthetic benefits as a whole system together. This prevented the need for acoustical ceilings or acoustical wall treatment and had benefits for the construction fit-out schedule because that was accelerated for less trades. And in this case, overall, the mass timber remained visible without compromising acoustical quality. Very clever solution here. The next 2 approaches we want to highlight are about structure. We're going to pull out the 2 primary themes we saw in the projects overall. The first was timber structure. We did see many projects across the submissions use timber in different ways. In some cases, this was CLT. It could also be timber stick framing or light timber framing, as well as applications like DLT. The second strategy we'll highlight is lightweight design. This included structural design efficiencies, grid explorations, examining different steel types and profiles, and exploring other redesign opportunities. Starting with timber structure, we're going to highlight Bunker Hill housing. This project estimated about 31% embodied carbon savings. And the primary embodied carbon reduction strategy, do you mind going to the next slide here? Thank you. The primary embodied carbon reduction strategy used here was a 7-layer CLT floor slab. This replaced all above grade floors and was actually in place of what would otherwise have been a standard concrete plank system. This approach was a standardization of the building components based on that use of the CLT, and this resulted in a significantly shorter construction period, reducing the cost of the project's general conditions and the interest expense in the overall development timeline. In this way, CLT actually realized cost savings compared to concrete plank. Because we highlight examples of timber everywhere else, we're going to leave that to one example here and switch over to lightweight design. The example we want to highlight here is the Cooper Center for Active Living. This project estimated about 27% embodied carbon savings, considering the interiors, enclosure, and structure. This design team started early in exploring embodied carbon. During DD, they compared a majority timber frame building to a steel and concrete building, and they estimated about a 50% savings at that stage from that comparison. They also estimated that that involved a significantly lighter structural system, about 50 to 75% lighter than a steel and concrete structure. And really, this overall lighter weight was the key on this project. They were able to reduce the size and weight of the supporting foundations and footings that also removed concrete volume from the project. But I think the most interesting piece of this whole story is that this lightweight design allowed them to eliminate otherwise needed ground improvement. The soil conditions here were poor, there was about 8 feet of urban fill, and they would have needed extensive ground reinforcing, such as rammed aggregate piers with a heavier steel and concrete building. And for anyone who's ever modeled deep pier systems, they are extremely carbon intensive. So basically, by selecting a lighter building type using CLT and stickwood framing together, they were able to lighten up the whole building and select a different foundation system. So hugely significant overall. Given the size of the overall project and that it was fully sprinklered, the project was also able to be classified as Type 5 construction. And this benefited reduced cost and added design flexibility. The team suggests that if the project was instead classified as a Type 1 or Type 2, they would have had significantly higher cost and fire requirements, like 15 to 20%. The final note here is that this project was able to be panelized and manufactured off-site and assembled in a much shorter schedule than steel and concrete building. These savings are estimated to be about 4 months shorter. All right, so the second project we'll highlight here is the Mass Maritime Lab Modernization Project. This estimated about 16% embodied carbon savings and really emphasized lightweight design. Overall, this project team was focused on avoiding overbuilding as a project priority from the earliest design stages. And they did this by really comparing different steel opportunities and looking closely at their concrete specs. So they looked at whether HSS columns or wide flange columns showed a higher embodied carbon footprint and how it contributed to the overall steel volumes or steel mass on the project. And what they found actually was that the HSS columns, while they showed slightly higher embodied carbon, their reduced surface area minimized the need for fireproofing materials. And really, they decided that this meant that two types of steel were very comparable in terms of their use as columns, and they ultimately opted for a mix of HSS and wide flange. As an aside, they also explored revising their concrete specifications and introduced a performance-based target into their specification, targeting a 25% reduction in GWP compared to NRMCA regional benchmarks. Back to you, Beth.
Thanks, Aurora. So procurement, so we talked about using less, we've talked about structural system approaches, and now we're going to talk about procurement approaches. And I think some teams tend to find this to be the easiest, and also they think of it as something that you can add later. And these kinds of approaches can include things like low carbon concrete, steel, gypsum, wood fiber instead of some foams, foam glass aggregate instead of XPS and gravel. And I think generally people tend to assume these are more expensive approaches when you go for procurement of lower embodied carbon materials, but that's not actually always true. We're definitely seeing foam glass aggregate being less expensive in our Massachusetts market as compared to XPS and gravel. Wood fiber, continuous insulation, sometimes prices in the Northeast, especially as HP Timber, their product comes out, is going to be on par with mineral wool. And low carbon concrete in Massachusetts, we tend to be finding that a 20% carbon reduction in mixed designs as compared to the Northeast benchmark is possible without much cost impact, if any at all, as long as you're starting early enough in the project. And so I'm going to talk a little bit about a low carbon concrete example. So the Treehouse Conference Center, which is a Harvard University conference center that's going to be built, they really were very aggressive on low carbon concrete. They went with a 70% cement replacement using ground glass pozzolan, and they also specified that there shouldn't be fly ash. So this is a very prescriptive approach to low carbon concrete. I think in other projects that we saw across the competition and that we're seeing in general, the key really to keeping costs down for low carbon concrete is very early engagement with a ready mix concrete producer as soon as the general contractor is chosen. And actually to go opposite of this approach, which was very prescriptive in what should be put in as replacement. And for cost control, the concept of going with a performance-based specification with a greenhouse gas limit for the concrete across the entire project seems to be the key thing for keeping costs down. And as I mentioned, like we really are seeing 20% without too much cost impact in our market. When you go with that more performance-based specification, the ready mix producers can take a look at what's out there, whether it's slag, fly ash, glass pozzolans, blended limestones. There's a whole bunch of things in the market that they can put in that could meet the needs of the project without impacting cost. And so that's why going with those performance-based specifications are important. One thing I will say is like across the board, whether you are able to get low carbon concrete in your market or not, asking for environmental product declarations for concrete is really, really important for moving the market. And here in Massachusetts, we have half the producers in the state now able to produce environmental product declarations based on a grant program that Mass EC's had that we copied the state of Oregon. And then keep an eye out because the National Ready Mix Association has a grant from EPA to be doing this nationwide as well. So really there's not an excuse for the transparency around the climate impact, the greenhouse gas impact associated with concrete mixes going forward. We also saw quite a few examples of low embodied carbon insulation products used throughout. So 24 Mass Ave is a 6-story new construction development in Cambridge that will add 56 residential units and retail. And it achieved approximately a 34% reduction, 36% reduction, mostly by switching out polyiso insulation products for wood fiber products. Bio-based materials, when they can be replacing foam products, particularly foam products that have a high global warming potential, a blowing agent is a really good strategy for reducing insulation procurement impacts related to embodied carbon. And though it wasn't used on this project, we have been definitely seeing a lot more, as I mentioned, projects in the Boston metro area using switching out for XPS subsurface, using foam glass aggregate as a replacement of XPS plus gravel. I actually know from our Passive House work of 2 general contractors who at first were resistant to the idea of using this, then used foam glass aggregate, either Glavel or Aero aggregate, and were really happy because it meant coordinating a lot less subs, and it ended up being less expensive as well. And so, like I mentioned at the beginning, these are the 7 major areas that we've given you case studies showing different examples. This is really like your guidebook as a designer for what you should be thinking about. If embodied carbon reduction is your goal, like we all need to learn how to do whole building life cycle analysis too, but I think some of these are just common sense strategies that we should be thinking about across the board. High impact, low cost strategies.